Okay, so here's a function. The first question is to find the domain and range. Next is to find the inverse function. And after that, find the domain and range of this inverse function. Okay, first of all, to find the domain is all allowed values to the function, right? So let's think about it a little bit. Can you plug in 0? Can you plug in 0? Yes or no? Yes. Can you plug in -1? Yes, because 3 minus -1 would be 3 plus 1, right? So you end up with square root of 4, which is perfectly fine. Okay. Can you plug in 10? Why not? Because you're going to end up with a negative. Okay. So what's the maximum value of x that you'll be allowed to plug in? 3, right? 3 is okay. You can take the square root of 0, which is 0. But beyond 3, that's not okay. So the domain would be all negative numbers are fine. Even some positive numbers are fine as long as it doesn't go over 3. 3 is the maximum you can go. Okay, now you could get that same answer formally just by saying 3 minus x has to be greater or equal to 0. You add x both sides, and now you have 3 like that. And if you write this in interval notation, this is what you get. Okay? That will be more formal way to get the answer, but you can just look at it and get this answer without having to do that calculation. All right. Now, what about the range? Well, we know that square root is always 0 or positive, right? Yeah. Square roots can never produce a negative number. Right? So that means square root minus 2 will be bigger or equal to? No, you subtract 2 both sides, and what do you get on this side? 0 minus 2. Okay? So you see that the value of this function has to be -2 or greater. The only time it gives you the actual -2 is when you plug in 3 into this function. Okay? So that tells us that the range is equal to -2 and every number after it. Okay? Okay, so that's part A. Now let's go to part B. Sorry, not part. This is part 1 of question A, and let's now go to part 2, which is to find the inverse function. To find the inverse function, you first have to introduce the y, switch x and y, and now you have to solve for y. How do you solve it? You add to both sides, square both sides, and then add y both sides, which gives you y plus x plus 2 squared equals to 3. And now subtract x plus 2 squared both sides. And you get y equals to 3 minus x plus 2 squared. Now going from here to there, this is not the only way. Some of you might prefer to subtract 3 and then divide by -1. That's also possible as well. Okay? But either way, if you solve for y, this is what you're going to get. Therefore, the inverse function would be 3 minus x plus 2 squared. Okay? Now part 3. What's the domain of this inverse function? Yeah? Yeah, see, the inverse function is obtained by switching x and y. And because domain is all the x values and range is all the y values, when you take the inverse, x and y switches so that the range becomes the domain and the domain becomes the range. So that domain, -infinity to 3, now becomes the range. There is a delicate point here, though. if you were just given this as some function and you were asked, what's the domain of this function, you would say, what? You have a function that's like this. What's the domain of this function? Do you see any square roots? Do you see any fraction? Do you see any log? So what's the answer? Yeah. All reals. Right? But don't write this though. Don't write this. Because that's not what the point. So you might ask, why is it that the domain of this is restricted, right? And that's where the fine point is at. So, see, this is not just 3 minus x plus 2 squared. This is 3 minus x plus 2 squared with an additional restriction. So, see, what's really happening here is that if you look at this, this is saying that y has to be greater or equal to negative 2, right? And since x and y is interchanged, you're really taking this one with y greater than negative 2, and you switch this x and y, and now here the condition is x greater than negative 2. And that condition is secretly passed down here, so there's a secret condition here. That's why the domain is like that. Now, another way to see the same thing is, see, square root of 3 minus x is 0 when x is 3, right? And then you only have graph on the left side, and as you go further left, the value increases, right? So the value goes like this. But then if you subtract 2, this entire thing goes down by 2, so you end up with something like this. Okay. So that's the graph of square root of 3 minus x minus 2. And if you take the inverse, the graph of the inverse is reflection over y equals to x, right? If you take this and reflect over here, negative 2 becomes the x value, 3 becomes now the y value. See, 3 was the x value. X and y is interchanged, right? Reflecting over this diagonal line means you're switching x and y. So now this point goes over here, and anything that's on the graph would stay on the graph, so it would be more like yeah, it will be more like this. Okay? So the actual graph of the inverse will be like this. It's a half a parabola. It's not the full parabola. If you had the full graph, then it would be giving you the full graph. But since this is the original function, you're changing x and y, it just gives you half the parabola. And that's why the interval, the domain is restricted. So that's like one point that's a bit delicate. Okay, let's figure out the domain of this function. What's the domain of this function? You can see it has a fraction, right? So if it has a fraction, what do you know? You can't have 0 in the denominator. When is the denominator 0? When x is negative 3. So the domain is really anything but negative 3. How do you say that? Well, here's the number line, and here's negative 3. That's the picture. Okay? So you end up with 2 intervals, right? Okay, so tell me. Negative infinity up till negative 3, and then union negative 3 to infinity. So taking the number line, erasing this negative 3 will break up the number line into two intervals, one piece and another piece here, right? And those are the two pieces. What about the range? Well, range is always hard. There are very special occasions where you can just look at the graph and find the range. In most cases, you need to think about the graph to find the range. So we'll hold off on the range for a while, but then let's just go straight to part 2 of the question. The part 1, this is the answer. And we're going to find the inverse of this function. Okay? So you have x equals to 2y minus 5 over y plus 3. So I took this function and switched x and y. Okay? That's what I have. And now I have to solve for y, right? So we multiply multiply y plus 3 both sides. Because that would kill the denominator on the right side. That makes the equation less painful. Let's multiply this out to see what we have. We have xy plus 3x equals to 2y minus 5. And here we are trying to solve for y, these two things. And it's a problem for us because y is in two different places. You somehow have to make that two different y into a single y in order to solve for y. You kind of get it, right? Yeah. If you have y in two different places, it's really hard to solve for the y. So what you want to do is you want to bring the y's to one side to put them close together to see if you can like somehow extract only the y from them. So we're going to move this 2y over here, whereas 3x should go the other way. Moving means I'm really subtracting 2y both sides. Yes?
Did you take the GCF out of the x and the 3x? The xy and the 3x?
So you see, there's a x as a common factor. So if you factor the x, but then you would go back to what you started with. So you don't want to do that. Okay. Instead, you want to subtract 2y both sides. So you get xy minus 2y. And then you're subtracting 3x both sides. So you have negative 5 minus 3x. And then now comes your idea, which is to see that y is common. So you can factor the y out. So what did we achieve here? There were two y's before. Now there's only a single y. So that means I can solve it. Yeah. That's the important part. Okay. Let's divide both sides by x minus 2. So you have y x minus 2 equals to negative 5 minus 3x. And you divide both sides by x minus 2. So these are gone. And you have y equals to negative 5x, negative 5 minus 3x over x minus 2. So that's the inverse function. Okay. Now, what's the domain of this function? What's illegal this time? Positive 2. Positive 2. 2 minus 2 is 0. So it'll be all reals except 2. What's the range? Well, it'll be the domain of the original function, right? Yeah. Okay. And looking at that, you see that the answer to this one will be negative infinity to 2 union 2 to infinity. So instead of having to take the trouble of graphing this, you're able to find the range by looking at the domain. Okay, domain of this function. There's no log or square roots or fraction, so x can be anything, so all reals. And let's take the same strategy. We'll hold off on the range, because maybe you can find the domain of the inverse function easily. Right? Okay, number 2, we're trying to find the inverse function. So let's switch x and y. So x and y are switched, and you get x equals to 3 times 2 to the y minus 5. And you have to solve this for x. How do you do that? Divide both sides by 3. And then take log base 2 of x over 3. Okay. So that y minus 5 is equal to log base 2 of x over 3. Now add 5 both sides. You have log base 2 of x over 3 plus 5. Okay? Now what is the domain? Well, inside the log, what's required? What's required for inside the log? So 0 cannot be plugged into log, and negative cannot be plugged into log. Okay, so you need x over 3 to be positive. Okay? So that means x has to be positive. So that's the domain. Domain is 0 to infinity. What's the range? And then whatever you wrote here would be the range here. Okay. All right, this next function. How do you get the domain? Whatever that's inside the log, what do you know? Has to be strictly greater than 0. It can't be 0. It can't be negative. It has to be strictly greater than 0. It has to be positive. So you subtract 7 both sides, divided by 2. That's what you get. And therefore, the domain is negative 7 over 2 until infinity. Let's hold off on the range and go straight to finding the inverse function. So y equals to ln 2x plus 7 plus 9. Switch x and y. That gives you x equals to ln 2y plus 7 plus 9, and you have to solve one by one. Okay, so subtract 9. Okay, what's the next step? Tell me. Yes, raise both sides to the base of e. Because then e and ln cancels. Remember, ln means log base e. So it's going to cancel with power over e. So you have e of x minus 9 equal to 2y plus 7. And subtract 7. And divide both sides by 2. And you get f inverse of x equal to e to the x minus 9 minus 7. Oh, sorry. Minus 7 is down here over 2. Okay. What's the domain of this function? What's the domain of this function? Huh? Where are you getting 2 from? Do you see a log? Do you see a square root? Do you see a fraction? Well, I do see a fraction, but the denominator never becomes 0, so that's not a concern, right? So what's the answer? Huh?
Technically, a log takes 10.
No, there is no log here. There's log here, but not here. Okay? In this function, there is no log. Okay? So the domain is all reals. Is it okay? All right. What's the range? Okay. What's the range here? Okay. That's what you do. Next question asks for the function f of x. F of x is domain, range, intercepts, and asymptotes. And you have to draw the graph using all the information you get there. Okay. So let's look for the intercepts first. First, how do you get the x-intercept?
Switch y and x.
No, switch x and y to find the inverse function. How do you get the x-intercept? Set what equal to 0?
No, y.
Y is 0, right? Yeah. Okay, add 1 both sides. Take log base 5. Okay, we learned one fact about log a of 1. What is this value? Does anyone remember? 0, right? So using that, the left side will be 0 equal to x. Well, you can do a quick calculation. 5 to what power is 1? 5 to what power is 1? Anything to the 0th power is 1. So use that, right? So you see that x equal to 0 is the solution to this. So 0 is the x-intercept. Okay? How do you find the y-intercept? So x is 0, right? So y is equal to 5 to the 0th power minus 1. Anything to the 0th power is 1. So you get 0. So in both cases, you get 0, comma 0. And that's the only point on the axis that's both an x-intercept and the y-intercept, right? If the graph passes through the origin, that would become both the x-intercept and the y-intercept, okay? All right, so that's what we figured out. Now, to find the asymptotes and also for the range, you have to know how to graph this. And you need to know the following. If you have y equals to a to the x power, the shape of the graph looks like this, with this being 1, okay? And this is assuming that a is bigger than 1. If a is between 0 and 1, it actually decreases, but just make sure that you know this one for a bigger than 1, okay? All right, so if you know that this is the picture for a to the x, you can start out by graphing y equals to 5 to the x power. What's that? It's like this, right? It's increasing like this, right? Okay, and then what is y equals to 5 to the x minus 1? What does this do? It makes the graph, go down 1, yeah. So what was at 1 will now go to 0. Okay? And the graph will be like this. Okay. Oh, there's something else I forgot to mention. See, in this graph, the x-axis itself is a horizontal asymptote. Okay. So that horizontal asymptote, which was here, is going to get shifted by 1. So you get a new horizontal asymptote at -1. What's the equation for the horizontal asymptote? Y equals to -1. Okay? That's the horizontal asymptote. All right, so now let's go for the domain. What's the domain? What's the domain of this function? -infinity to infinity. See, there is nothing stopping you from plugging in any positive or negative number here. What about the range? Since we have the graph, we can now talk about the range. What's the range? Yeah, it never goes below -1 and it never touches -1. So the range is -1 to infinity. Okay, now we have to do the same thing for the inverse function. But it's quicker to just graph the inverse function than to find the intercepts of the inverse function. So let's think about how to graph the inverse function. Okay, so here's y equals to x. That's the diagonal. And what you're doing is you're flipping this part over the diagonal, right? If you do that, what happens is that the horizontal asymptote becomes the vertical asymptote. So here's -1, and you have this as your vertical asymptote. The horizontal asymptote becomes that. And what's on this side, when you flip it over, it will be a graph on the other side, right? So the graph that you get on the other side will look like that. So that's the graph. And already from here, you know the intercepts and the asymptote. Okay, so first of all, what's the asymptote? X equals to -1 is the asymptote. And of course, finding the inverse function has to do with switching x and y. So whatever you had as y equals to -1 will now become x equals to -1. So that's the asymptote. And then x, y intercepts are, except is just 0, 0. That's the only place where the graph passes through the x-axis or y-axis. And then domain and range will just switch those two around, right? So domain would be -1 to infinity. Range would be -infinity to infinity. Okay. Now let me see. Did I ask for finding f inverse? Oh, it does say so. Okay, so I didn't write over here, but it also says to find the inverse function. So let's do that. Let's take this, switch x and y. So x is equal to 5 to the y minus 1. Add 1 both sides. Take log base 5 both sides. Which is going to cancel the 5. And therefore, the inverse function is log base 5 of x plus 1. Okay, so let's try this next one. So for this one, let's find the x-intercept. So set y as 0 for the x-intercept. Okay, how should we solve this? Yeah? No, natural log will be ln. We're trying to solve for x. Yes. Not e. E would be if it's ln. Yes? Put it over 2. Right? So put it over 2. So that these two will cancel out. What's 2 to the 0th power? If 1 equals to x minus 1, and therefore x is equal to 2. Okay? Let's look for y-intercept. Y-intercept is, you set x as 0, which gives you y equals to log base 2 of negative 1. What's that?
You can't do that.
You can't do that. That's the correct answer, okay? You can't plug in 0 or negative inside the log, so this will be undefined. So that means no y-intercept. In other words, the graph will not pass through the y-axis. All right. Now, what's the domain? X minus 1 has to be what? Positive. Has to be greater than 0. You add 1 both sides. So what's the domain? 1 to infinity. That's the domain. On the other hand, the range would be negative infinity to infinity. Right? So because the log function goes from negative infinity to positive infinity. Okay, so what is this graph? Well, we know that at 2, 0, it's going to pass through, the graph will pass through 2, 0. And here's 1, and you shouldn't have any portion of the graph on the left side of 1, right? Nor 1. There shouldn't be anything on 1, okay? And you should also know the generic shape of the log graph. The log a of x, if a is bigger than 1, then the graph of y equals to log a of x has the following form. Okay? So if you knew that, then, and if you knew that this would be a vertical asymptote, this would be the vertical asymptote, right? So you're going to have this as the graph. So that's the graph if you knew this. So that's one way to graph it. Another way to do it would be to start from y equals to log 2 of x. Okay. Since in general that's the shape of the graph, log 2 of x would still be like this, right? Now what happens if you go from log 2 of x to y equals to log 2 of x minus 1? What's happened from here to there? The graph moves 1 to the right, so plus 1 right. So that's exactly what happened. This 1 now becomes 2. The vertical asymptote that was at 0, which is x equal to 0, now will give you the vertical asymptote x equals to 1. Right? Okay? And you should also notice that indeed the range is from negative infinity to positive infinity. So if you aren't sure why it's this, you can look at the graph that it goes from negative infinity to positive infinity. And now we should draw the graph of the inverse function. Okay, if it passes through 2, 0, where does the inverse function pass through? 0, 2. Where is that? 0, 2 is over here. Right? If the x equals to 1 is a vertical asymptote, what kind of asymptote does the inverse function have? Horizontal with y equals to 1. So here's 1, here's 2, here's 1. Right. And then it'd be like this. Oh, sorry, that's not right. I drew it as if this is an asymptote, but it's not. It's like that. Because after all, it should be symmetric with respect to the diagonal. Okay. So an easy way to see if you drew it correctly would be to draw what you think is what you would get if you flip over the diagonal, and you rotate this around and see the picture is symmetric. So if you rotate that 45 degrees, you're going to get something like that, right? With this would be x equals to 1. This would be y equals to 1. Right? That should be the graph. And it's a lot easier in your eyes to see the symmetry when it's along the vertical line, because human beings are designed to see the symmetry. You know, there once was an experiment with kids to see if little babies can tell if a person's face was beautiful or not. And it seemed that babies did prefer one face to another, but their way of figuring out if a face is beautiful or not was how symmetric it was to the vertical, because human eyes have like this tendency to be able to tell the symmetry with the respect to vertical. Yeah. So you're probably good with knowing whether this is symmetric, whereas trying to figure out if this is symmetric over this diagonal line, that might be a bit of a challenge. Okay, let's find the exact values. So for this one way to do it would be to write this as 27 is 3 to the third power. It's a good idea to know what this number is a power of 3, whatever this base is. Right? And we know that 3 times 3 times 3 is 27, so you write it like that. And then 1 over something can be made to be not a fraction by introducing a minus power, right? If you know that, then you can get rid of the 3, which will give you negative 3. Now let me show you an alternative solution, which is to say that if you divide, what do you know about division? Division changes to subtraction, right? And log of anything of 1 is equal to 0. And you can rewrite 27 as 3 to the third power, so when you cancel these out, you get negative of 3. You can solve it in either way. Both will give you full credit. Okay, let's try this one. This one you have multiplication. So what can you do with multiplication? You can split into 2 logs. And what becomes of the 2 logs? Addition. Addition between 2 logs, right? So log base 2 of 2 plus log base 2 of square root of 2. And in both cases, you want to write as some power of 2. 2 is 2 to the first power. Square root is 2 to what power? 2 to what power? 1/2 power, yes. So they cancel, and you get 1 plus 1/2. What's that? 3 over 2, right? Okay, this time you have division. What do? Subtraction between two logs. And 49 is 7 to what power? 49 is 7 times 7, right? So 7 squared, yes. And cube root is same as 1/3 power. So this is 2 minus 1/3. Well, 2 is 6 divided by 3. 6 divided by 3 is 2, right? So you can rewrite 2 as 6 over 3. And since they have this common denominator, now you do 6 minus 1, which is 5 over 3. Okay, so for this one, I have some kind of an exponent. What can you do with that? You can move it in front, right? You can make it jump over the log. So this would be 7 times log 5th root of 10. Oh wait, I don't see any base. What does that mean? That means it's log base 10. And 5th root is same as what power? 1/5 power. So when these cancel, you end up with 7 times 1/5. That's going to be 7 over 5. Okay, so this next one is not like the others. There's no way to write down 32 as some power of 8. Oh, there is a way, but it will take you some time to find it out. It's just too much. So instead of going that way, we have to use something called the base change formula. So let me try to write down the base change formula first, and let's think about what that means. The base change formula states that log A of B is log base C of B over log base C of A. And if we apply this formula to here, hoping that it might work, since A is 8 and B is 32, the right side would say log C of 32 over log C of 8. But what is C? You might ask, right? What is C? Where does that C come out of nowhere? The answer is C can be anything you want. And it's called the base change formula because it tells us that you only need to know the logarithm of one base fully well, then you can always calculate in other bases. So, for example, your scientific calculator only has ln or log base 10, right? So in one of these, you will see only ln or log. Okay? Log is log base 10. But still using that, you can use your calculator to calculate this value if you choose C to be E, which will become ln. So you can do ln of 32 divided by ln of 8, and that will give you the value, right? Or you can also do C as 10, which will be log of 32 divided by log of 8. You can do that again. Okay? You can do that as well, okay? So in either case, you're going to get the same exact answer. However, there's a way to solve this without using a calculator. Yes. You would want to do log base 2. Why is that? Because 8 and 32 are both powers of 2, right? So if you use C as 2, although other values of C is fine if you can use the calculator, if you want to solve this without a calculator, the obvious choice will be log base 2, because then 32 is 2 to the 5th power, and 8 is 2 to the 3rd power. And they cancel, and you get 5 over 3. And that's the answer. And you can check with your calculator that indeed ln of 32 divided by ln of 8 will give you 1.66666 which is 5/3 if you write in decimals. Yes.
So my calculator does have the input for one second, input everything, so if I just plug it into my calculator, would you take off points for figuring it out?
You have log with any base?
Yeah.
Oh, that's nice. Yeah.
Would you still take points off though? If I submit?
Well, I would, here it says find the exact value, so decimals are not allowed. So you have to,
More exact than a fraction.
huh?
Just in a different form.
No, it'll be, if you have decimals, it always has a round off error. You have to round it off somewhere. So you have to change that to a fraction. Well, there is still some way, which is to take that decimal and you can do the functionality to convert to fraction. There should be something like that. Convert decimal to fraction. Oh, there it is. I think it's symbolic to decimal, S to D. So if you do plot that in and you press this, you get the full fraction, which is the full credit. In class, I gave you a quick guide how to change from exponential form to logarithmic form or vice versa. But let me try to explain what these mean first. So A to B equals to C. If you have some number to some exponent gives you a number, that's called an exponential form. Okay? And this is equivalent to saying that B is equal to log base A of C. Okay? Now, how do you know that they are equivalent? Well, you just have to take log base A both sides. Log base A and A will cancel, leaving you with B on the left side. On the right side, we'll get log base A of C. You get that? So if you have an equation that's of this form, it's called the exponential form. If you have an equation of this form, it's called the logarithmic form because that has a log. Okay? And they're saying the exact same thing. Okay. And as I just explained, going back and forth just simply has to do with taking log to get to this place. And if you start from here to go back, you just have to raise it over power of A. Just make the base A and you raise it to each side. And then since this is the logarithmic form, we're going to do exactly that. Okay? Take both sides and raise it over 7. So you get that, right? And then if you cancel, you get 49x equals to some exponent. And that's called the exponential form. And you don't simplify anymore. This is the answer they want. Okay. Is that okay? Yeah, all right. All right, so over here, how do you change that to logarithmic form? Take log 4. Okay? That's it. You just stop right there. After canceling the log, that's it.
Does it matter if you use brackets or not?
You could put here, that's fine. Yeah.
Is that Z?
Z, yeah, Z. Okay, so this first question is about expanding into many logs as possible, and then if you have any fractions, if you have any exponents, you have to move it to front. Okay? So let's try that. First, you have a division. What do you do? Subtraction between two logs. Okay. And then let's put it over here. And this is a multiplication, right? Multiplication turns into addition. Multiplication, addition. Okay, I made a mistake. Where did I make a mistake? These two should be inside the parentheses, right? Because, see, this minus is applied to this entire thing, so this minus should be applied to both of these. If you forget the parentheses, then this wouldn't be applied to this, and you'll get a minus error, okay? That's a very common mistake. You have to know how to use your parentheses right. Okay, now this 2 can move to the front. Square root is half power. Cube root is 1/3 power. Then this minus applies here. And you make these remaining exponents to jump. So let me write over here. Equals to 2 ln of x plus 1/2 ln of y minus 1/3 of ln of x minus 2 ln of y. Okay, I made all the numbers jump to front. But then you see some like terms, right? These two are like terms. They both have ln of x, so you have to combine them. What's 2 minus 1/3? 2 is 6/3. 6/3 minus 1/3 is 5/3. Now this, when you subtract something bigger from the smaller one, I like to write it like this. Minus 2 minus 1/2. Okay. Put a minus outside so that this will become bigger minus smaller. Yeah, that's a nice trick to use. 2 is 4/2. So what is that? 4/2 minus 1/2 is 3/2. That's what you get. In question 4D, you're doing the opposite, which is to combine. So you have many different logs, and what you're trying to do is to put everything into a single log. That's the idea. Now, to go from many logs to a single log, you basically want to make use of the following rule, so that if you add, you end up with a single log with two things multiplied inside the log, right? Or if you subtract, then it's division. So those are the rules that you want to make use of. That's how you go from many logs to a single log. But although you have a minus, you can't use this rule. Minus becomes division because you have 4 and 2 getting in the way. Yes?
I have a question.
Yeah.
So for when it says expand,
Yeah.
why did you start adding them back together to get the final answer? Wouldn't the final answer be 2 natural logs?
Oh, you think this is the answer? Well, the thing is, you have to expand and simplify.
Okay.
Yeah. So expanding means you make it into distinct logs as much as possible, and all the exponents should be brought outside.
Okay.
But then if you have any like terms, you still have to combine them. Okay. All right, so back to this question. 4 and 2 are getting in the way to put these two together into a single log. So what should we do first? You have to get rid of the 4 somewhere. Okay. Where should this go? Huh? Z to the 4th, right? You have to make it jump back up there. 2 also, you want to make it go up here. 5. So when you move these coefficients out of the way, then you're able to use these rules. Subtraction means division, addition means multiplication. So subtraction makes it log z to the fourth minus becomes division, and you have this. And over here, addition means what? Multiplication. Okay. And therefore, when you multiply, like this. Okay? Yeah, so that's the answer. Now, alternatively, let me show you this quicker alternate solution. You can move this minus 2 as well. So instead of thinking of it as minus 2, think of it as plus negative 2, so that this thing becomes log z to the fourth plus log x to the negative 2 plus log y to the fifth plus log of 5. Then since everything is plus, we just have to multiply everything at once. Now I have put everything into a single log, so that's an alternative full solution, full credit solution. Okay, so let's try these. First of all, how would you solve this? And you get x equals to log base 3 of 4. Okay, that's the answer. Now there's an alternative solution, which is instead of taking base 3, you can also take ln both sides. But because this is log base e and this is 3, they do not cancel. Instead, what you can do is you can pull the x in front, make it jump over the log. And now you divide everything by log of 3, and you get x equals to ln of 4 divided by ln of 3. And this is a perfectly valid solution. This is also full credit. Now, if you're wondering why log base 3 and 4 is the answer here, as well, on the other hand, you have a different looking answer. They're really the same because of what? Why are these same? Base change formula. The base change formula says this is the same as this. Okay. All right. For this one, what should we do? You first have to get rid of x. How do you do that? Put it over x, right? They cancel, and you get 5 equals to x to the 7th power. How do you solve this? Well, you can take 1/7 power both sides. And what happens to these two? They multiply to become 1, right? So that gives you x to the first power equals to 5 to the 1/7 power. So that's x equals to 7th root of 5. Yeah. But you really don't need this much work. You can just go from here to straight to here because, I mean, what is the meaning of 7th root of 5? The meaning of this is the solution of this. So you don't really have to write these. You can just go from here to there right away.
Would it be okay if the answer was 5 power?
That's also fine too. So this will be also full credit. Okay. So either x equals to 5 to the 1/7 power or x equals to 7th root of 5. Either will be good. Okay, for this one, what should we do? Yeah. Oh, so that's a really simple question. Yeah, so for this one as well, you could leave it like this, or you can also write it as 1/8 root of 6. Either will be given full credit. So for this one, for this question, the parenthesis shouldn't be there. This question, this is totally different from this, okay? So make sure that you distinguish these two, and what you do is you move the 2 down here. It's 2 log of x equals to log of x plus 2, and then you subtract log of x both sides. What's 2 log of x minus log x? 2. Now what do? You raise it over 10. So cancel the log and you get x equals to 100. That's the answer. Okay, for this one, when you remove 2, what happens? Plus minus square root of 9. That's always what you do when you remove the squared, right? Yeah. So you get ln of x equals to plus minus 3. How do you remove ln? E. So they cancel and you get x equals to e to the 3 or e to the negative 3. So that's the answer.